What is going on, everybody? Hope everyone had a really good Memorial Day weekend. Again, nearing the end here, only a few lessons left, and then we are out for summertime. We're going to be looking at normal distribution. It's a pretty common thing. If you've been watching the news recently, you've probably heard it maybe once or twice. And so many populations have a distribution that can be well described with what is known as the normal distribution or the bell curve. That's normally what they would say. This curve shows the percent or proportion of a normally distributed data set that lies a certain amount from the mean, okay, or the average. So here's what the bell curve looks like, okay, and it's pretty standard. And this would represent the percent that is above the mean, and this would represent the percent or population that would be below the mean or the average, okay? And each one of these represents a half, okay, what we're going to call a standard deviation. So you're either going to be a standard deviation above, or you can be a standard deviation below the mean. Okay, now if you're looking at the mean, okay, that's right in the middle, that's going to be your 50%, okay? So if we're going to start looking at being away from a standard deviation, what percent are you away from that? So each percentage represents the approximate proportion of the data that would fall in the range of scores in a normal distribution. It is the probability that a score in that section occurs. So for a population that is normally distributed, find the percentage of the population that lies. So what percent of the population would be one standard deviation from the mean? So if you are one standard deviation from the mean, you are 19.1 and 15%, right? So that would represent, if you are above the mean, that would represent 34.1 of the population, right? And then if you're one standard deviation, you can be above or below, so you can go in both directions. So then that would be this one and this one, also the same 34.1. So if you think about it, it makes sense, okay? This is the largest portion right here, being one standard deviation. That's 68.2 when you add up all of those numbers. So 68.2% of the population would be there. 68.2%. Now, what percent lies within two standard deviations? Okay, so the same game. You're just now going to use what you just did, and now continue. And now you're going to have to add the 9.2 and the 4.4. Then you're going to have to add the 9.2 on the 4.4, going two standard deviations. So basically, you're adding up all of these numbers. Okay, so that's going to be from here to here, and that's going to represent. Excuse me, we're trying to make videos here.
Sorry.
Thanks. Sorry, the studio's a little loud today. 95.4%. Okay, that's adding up, and then if you look, that's pretty much almost everybody there. 95.4%. And now if you're going to go even further, you're going to represent three standard deviations. Well, three standard deviations is all of this above and below. So you're going to add up all of these numbers. Or if you want to make your life easier, just subtract the two that you're not using, which is 0.1 and 0.1. And that's going to be 99.8%. Okay, lies more than three standard deviations away from the mean. So if you're more than three standard deviations, you're either this guy or this guy. So that is 0.2%. And lies between 1 and 2 standard deviations above the mean. 1 and 2 standard deviations above the mean. So now this one will be a little bit different. So before I said just one standard deviation. Now if you're just being one standard deviation, you can either be above or below, so we counted them both. But in this case, when I said between 1 and 2 standard deviations, you're only looking at these two here, the 9.2 and the 4.4. You don't count the other sides because that's below. So then you'd add those two numbers up, and that's going to be 13.6%. So that's just kind of going through and just adding those percentages up. Here we go again. Looking at it again, we talked about it before. A percentile indicates a point below which a percentage of data falls full. A percentage of data values fall. In a normal curve, the mean is the 50th percentile. Okay, so there's your mean right there. It's in your center. That's going to represent 50%. So now, if I'm given this bell curve here, name the percentile at each mark of the curve, where x bar is the mean and represents 0 mark. So right here, that's going to represent 50%. Okay, so if you're going to be, God bless you. Okay, if you're going to be 1 standard deviation now, okay, because I'm adding one standard deviation above, that's going to be the 50% plus the 19.1 and the 15. So I do 50 plus 19.1 plus 15, and that's going to be 84.1. Then I'm going to do 1 standard deviation below. 1 standard deviation below, so I'm not going to add, I'm going to subtract because I'm going down. So I'm going to do 50 minus 19.1 minus 15, and that's going to be 15.9%, or I shouldn't say percent, I should say the 84th percentile, 15.9th percentile. Okay, these represent the percentiles. 2 standard deviations above, okay, you're going to add the 50 plus all of these numbers here, the 19.1, the 15, the 9.2, and the 4.4. Okay, you're going to add up all of those, and that's going to represent the 97.7th percentile. And then, okay, you're going to go to the last one, you're going to take that mean, which is 50%, and you're going to subtract the 19.1, the 15, and the 9.2, because that's your 1.5 percentile, and that's going to be 6.7th percentile. Okay, so there is finding the percentiles that you're in. All right, so that's just kind of your basic look at your bell curve. Now let's just make it a little bit easier and go into your calculator. So using the calculator to find probabilities for normal distribution. So the graphing calculator can also find these proportions or percent values without having to think about z-score. So no matter if you have a newer calculator or an older calculator, when you hit second vars, I should turn it on, second, broken, where's vars? There. You would see number 2, it says normal CDF, normal CDF. Now, things will get different from this point because when I hit second and then I go down to number 2 and hit enter, it's just going to do this. If you have the newer calculator, you're basically just going, it's going to have like a list format, and you're going to put in the lower bound, the upper bound, the mean, and the standard deviation. Okay, and I'll show you what that means in a second. And then you would hit enter, and then it's going to give you a decimal. You multiply that decimal by 100, and that's going to give you the percent. Okay, that's going to give you the probability of a score in the interval occurring. So when we're talking about an interval, the interval is going to have it's going to be between two numbers. So it's a lower and an upper bound. So here's our first example. So given a normal distribution of values for which the mean is 70, so that would be going here, and the standard deviation is 4.5, that would be going there. Use your calculator to find each. The percent of values that are between 65 and 80. So that means that 65 is my lower, 80 was my upper, and then my mean is 70 and 4.5. Okay, so go ahead. So if you have the old calculator, you're just gonna put it in and hit comma. If you have the newer calculator, it should say lower, upper, mean, and standard deviation, or something along those lines. But it's pretty much the same order here. So I'm going to be doing 65. Then I'm going to be doing 80. Then I'm going to be doing 70. And I'm going to be doing 4.5. I hit enter, and it's going to give me this number here. I would multiply that number by 100. And 85.3, we'll round it to the nearest percent. So I'm going to say 85%. So 85% of the people would be between 65 and 80. So inclusive means just you include those numbers. Like I'm not going to use 66 and 79 or something like that. All right. So that's if I'm telling you your lower and your upper. Now, what happens in B, we're saying the percent of values that are less than 62. So if you're less than 62, we don't know, okay, if you think of a curve here, we don't know how far or how low these scores go. So when you're doing this, and if it's saying less than or greater than, well, they're not giving you a boundary. They're not saying start here and end there. What you're going to do is you're going to basically put in infinity. Infinity just means it keeps going. So you have to understand, or you have to know, well, is the number they give you, are you going below that number or are you going above that number? Because you need to know, is the lower going to be that number or is the upper going to be that number? So the percent of values that are less than 62. So if you're 62, to be less is this way. And it could be anything. So what we like to do is when you don't have, whether it's a start or a lower or an upper, you use 1,000. Okay. So if you're using a lower value, which we are here, I'm going to be using negative 1,000. So when I go to put this one into my calculator, when I use my normal CDF, I would be putting in negative 1,000, that's basically negative infinity. Then I want it to go up, well, I'd have to put 61, right? Because it says less than 62. Then I would be doing my mean, which is 70, my standard deviation, which is 4.5. Bingo, bango, throw it in there. Let me do it one more time for you guys. So I would do second vars number 2. Then I would be doing negative 1,000. That's like negative infinity. Then I'm going to be doing 61. I didn't use 62 because it said less than. Then I'm going to be using 70, and then I'm going to be using 4.5. And then there you go. Take that number, multiply by 100, and 2.2 or 2.3 or 2%, whatever you want to call it there, would be the value of percent of people that are less than a 62. So there's not that many people there. All right, so here for this one, the way I'm going to put this in my normal CDF in my calculator, greater than 82. So if I'm greater than 82, what's the smallest number? 83, because you're greater than 82. Now, if you're greater than 82, what's the largest number? Infinity. So I'm going to put 1,000, right? Because you can't put infinity in the calculator. Then I'm going to do 70. Then I'm going to do 4.5. I'm going to put it in as my normal CDF, multiply it by 100, and it's going to be an even smaller number because it's going to be like 0.19, blah, 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 blah. Multiply that by 100, and I'm going to get 0.2%. So that's an even smaller amount of people that got greater than an 82 on this test here. All right, let's just keep practicing this. All right. So, exercise 4. On a standard deviation exam that is normally distributed, Chris received a score of 85, which was exactly 2 standard deviations above the mean. If the standard deviation for the exam is 4, what is the mean for that examination? Okay, so basically what that looks like, so this is the mean. Now, if he is 2 standard deviations away, okay, and they say that the standard deviation from the exam is 4, that means if that's 4 and that's 4, right? So it looks something like that. So if his score, what was his score? His score was an 85. Well, let's work backwards. Subtract 4, subtract 4. So that means that the mean on this test was a 77%. So that was right here. So 50% of the people got a 77. Since he was 2 standard deviations away with an 85, I just subtracted out 2 standard deviations. All right, exercise 5. 95% of the scores on a standard deviation test range from a 78 to a 92. Which could be the standard deviation in this one? All right, so if you're looking for the standard deviation, you're going to subtract those 2 numbers, and then we're going to get 14. Now, since the test ranges from 78 to 92, and then there are, when we were looking at it, say on your mean, you have 2 and 2, 4 standard deviations, that means that you're going to end up with around 3.5%. 3.5. So each standard deviation represents 3.5. Okay, here we go, number 6, and then here is what the questions will look like and how you'll know which kind of, whether you're going to be doing adding or subtracting or using the calculator. Each year, the College Board publishes the mean SAT score and a standard deviation for the students taking the test. True story. SAT scores are normally distributed. Assume for a group of students that the mean SAT score is a 500 with a standard deviation of 100. Find the score that is one standard deviation above the mean. So here's your mean. So if you're going to go one standard deviation, you're moving 100 points, so you're going to be at a 600. Find the score that is two standard deviations below the mean. So same game, except you're going to be going this way. But you're not going to be going one time, you're going to be going two times. So 500 minus 100 is 300. What percentile would a student be in if he or she scored? All right, so now here's how I know if I'm going to be using this normal CDF, because I'm asking for a percentile and I'm giving you their score, right? So let's start off here. I got a 500. Well, the mean is 500. Where the mean is always what percentile? Good, 50th percentile. Okay. Okay, so 50% or 50th percentile. What percentile would a student be in if he or she scored a 450, right? So if you're from 450, then what you're going to be using is you're going to be using your normal CDF. So if you're looking at this, right, now this is where it's important. So 500 is the mean, so this person is below the mean. This person is below the mean. So when I go over here, I'm going to go into my calculator. I'm going to do second vars number 2. So that means what percentile would a student be if they scored? So where did they lie? So I would do, let's see, if I said the lowest was negative 1,000, your highest was what she got, the mean was 500, and your standard deviation was 100. Multiply that by 100, and you get 31%. Okay, so there you go there. Okay, now, if you look at this one here, this person got a 750. So they are above the mean. So I'm going to be going from 750 to infinity. So I'd be doing 1,000. So I would be doing second vars, normal CDF, 750, 1,000, 500, 100, and you have 0.006. Multiply that by 100. Now, what I do? 0.006 times 100 is not 0.6. It's not 0.6. Oh yeah, it is 0.62 right now. All right, so that person is not in the 0.62nd percentile. They're way up here. They're super geniuses or something, right? So because I'm above, you have to minus 1, right? Oops. So it's 1 minus, I think it was like 0.6 or something like that. It's 100 because you have 100%, minus 0.6. So this person lies in the 99.4th percentile. Okay, so again, just to kind of clear up any confusion, which I'm sure I just did, when I did the normal CDF and I multiplied by 100, I rounded it 0.6, right? Now that person, okay, remember the mean was right here at 500. So think about it. One standard deviation is 1, 2 standard deviations is 2, and that person's sitting up here. This person is really, really smart, right? So remember, it goes up to 100 percentile, that's your highest. So if you do 100 minus that 0.6, that's going to give you, well, that person's sitting at the 99.4 percentile. Now you might say, well, why didn't I do that on the last one? Well, because on the last one, you're here and you're below, so you don't have to subtract from 1. That's why it's important to have an idea of where you are. Alright, so now in these ones, you're just practicing, you're just doing normal CDF, so if you want to hit pause, get all of your percentiles, awesome, see if you get them right. Alright, so in 2007, approximately 1.5 million people took the SATs. Approximately how many of them would have expected to score? Okay, so this is your normal CDF. You need to figure out what percent of the students were even there. So my lower bound was 400, my upper bound was 500, my mean was 500, and then it was 100. Then you got 34.1. Now this is the percent, but now they want to know how many people. So you're going to multiply that by the total number of people, and that's going to be 512,017 people. So it's the same game, except now if you want the actual number, you multiply that. Alright, so here you're going to do 300, 400, 500, 100. You're going to get 0.1359. But did I multiply that? 304. And then you're going to multiply that by 1,500,000. Oh, I didn't. Okay. And you're going to get 20,308.58. 203,858 people. And then again, last one, above 750. So if you're above 750, you're going to use 751. You're going to be going up to infinity. 500, 100. That's 0.0060. Okay, these are really smart people. And there were only 9,055 of them. Okay, here we go again. The height of a 16-year-old teenage boys are normally distributed with a mean of 66 and a standard deviation of 3. Jabari is 72 inches tall. Which of the following is the closest to his height percentile? So, if he is 72, then I don't know, up to infinity, because he's going to be above the mean. Then I'm going to be using the mean, which is 66, your standard deviation, which is 3, and I am going to be getting 0.02. Okay, now this person again is above the mean, so you're going to be subtracting by 1, and you're going to end up with the 98th percentile. Oh, I should be subtracting by 100, because it's 100%. So it's basically 2% minus 100, so that's going to be 98th percentile. Last one here, okay? The amount of soda pop in a standard can is normally distributed with a mean of 12 ounces and a standard deviation of 0.6. If 250 soda cans were pulled by a company to check the volume, how many would expect to have less than 11.1 ounces in them? Okay, so same kind of game here. So you're going to find your distribution. You're going to multiply that number by 250, and then you are going to get how many of those cans had less than 11.1. So let's see. So if you're less than 11.1, that's going this way, and then okay, here's your 12. You're moving by 0.6, right? Now 11.1, since you're below, so that means your lower bound is going to be negative 1,000. Your highest is going to be 11.1. Your mean was 12. Your standard deviation was 0.6. You're going to get 0.0668, multiply that by how many cans there were, and you're going to get 16.7, or about 17 cans. Alright, so there we go. That's using your bell curve, that's using your normal CDF to find percentiles. Leave some comments, let me know if it is helpful for you.